Hello everyone, and welcome to lesson 3.1, which is on expressions. This lesson sets up our entire chapter 3 and lets us know exactly what an expression is. So if you look on the screen here in blue, you'll see that an expression is a math statement without an equal sign. This includes a combination of variables, numbers, and math operations. Where I want to draw your attention immediately is this right here, where it says without an equal sign. A lot of times people get confused on the difference between what an expression is and what an equation is. That little phrase, without an equal sign, tells us the difference. So you can look in red. I have 4 examples on the screen that explain what an expression actually is. None of those 4 examples have an equal sign. They can have different variables, they can have different operations, and that's fine. With expressions, our job is to simplify everything and do what we can to make the problem as small as possible. These 4 examples don't really have anything that we can do. They just serve as 4 different options or 4 different versions of expressions for you to get an idea. The first one is just y plus 4. No equal sign, there's nothing to solve, there's nothing to simplify, we can't reduce anything, it just is what it is. Example number 2, 3x plus 1, a little more complicated, but still no equal sign. Then you have b divided by 2. Again, can't do anything with that. No equal sign, nothing to solve. It just is what it is. And then the last one, 2x plus 1 divided by 4 minus 3. Lots going on there, but there's nothing that we can reduce, not a lot we can simplify. That expression is just an expression. Eventually, maybe if we were given a variable, we could substitute and solve, but for our purposes today, an expression is just a bunch of math operations, numbers, and variables that are put together but do not have an equal sign. Now, to get more specific into what we are doing today, we're going to be talking about translating English sentences into math expressions. So, for example, you could see things that will say 2 plus an unknown value, and that would be 2 plus x. Or you could say the difference between a number and 7. Different things like that. This chart here in this list lets us know which words go with which math operations. So, for example, if you look across the first row, you can see that everything is divided into the 4 math operations. So the first thing that we see under addition is sum. A sum is what the answer is called in addition. Similarly, you will see that you have difference underneath subtraction. That is what the answer of a subtraction problem is called. The answer of a multiplication is called a product, and the answer for a division problem is called a quotient. Going back through, you will see 4 words that describe each math operation again. Plus obviously goes with addition, minus with subtraction, times with multiplication, or divided by for division. Past that, you're going to see a couple extra things for addition and subtraction in this section. You'll see more than, which means that we're going to add something onto something else. Less than means that we're going to be subtracting something away. And then also with subtraction, you will also see a phrase that says taken away from. And we're going to get into those in our examples for today. But what I would do if you're watching this and you're trying to get this content down is just write this chart out just like you see it and know which phrases and which words are associated with which math operation. That's really going to help us solve these problems moving forward. Okay, let's just take a quick look at our examples. We have 6 different examples to look at today. The first one is 15 more than a number is divided by 2. So when we look at this, it's always a good strategy to read the problem and then reread the problem to pull out important information. So the first one is 15 more than a number divided by 2. Okay, so the very first piece that I have to look at is going to be right here, and I'm going to kind of put it in brackets, is that 15 more than a number. Well, we know that more than is going to be a plus sign, and then we get to this phrase here, a number. Well, a number is going to be our general term for a variable. So we have 15 more than a number, so 15 plus x, and then after we take that, which I'll just go ahead and write that, I wrote that as x plus 15. You could do it either way, but generally anytime you see the words more than or less than, you put that number on the end. So it's usually backwards from the way that it's written. So 15 more than a number, that's going to be x plus 15, is divided by 2. So we have the divided by sign and 2. And that's how we do that. Now, some people will probably have some trouble with knowing when to group that. And what I would say to you is, when you read and reread, ask yourself, is just one thing being divided by 2, or is everything being divided by 2? And in this case, everything that's in those blue brackets, the 15 more than a number, right? That x plus 15 is being divided by 2, and so that's why the problem is set up the way that it is. All right. Moving on to number 2. Number 2 says the quotient of D and 5 times S. The quotient of D and 5 times S. So, first thing that we know is that quotient is division, right? D is our variable here. And then we have 5 times, which we know is multiplication, S. So what I know that I have to do here, rereading and making my notes, right? 5 times S, the quotient of D and 5S. Okay, so what that tells me is that I have to take D and I have to divide it by 5S. So just by following, the rules and knowing what's happening and knowing how we're doing things, we can kind of find these answers. In number 2, it says the quotient of D and 5 times S. So I knew that my main problem was going to be division because I'm looking for a quotient. It says D is the first part, so I put that in the numerator. And then it says 5 times S was the second part, so I put that in the denominator. All right. Number 3, it says the difference between 20 and an unknown number. Okay, so difference we know is subtraction. Then we have 20, and we have an unknown number, which is just another way of saying our variable. So if I just need the difference between 20 and an unknown, that's just going to be 20 minus x. Moving on to example 4. Example 4 says 1/2 the product of L and W. So we start by looking through that again. 1/2 the product of L and W. So the first thing I see is 1/2, which is just a half. Product, that means multiplication. L and W are our 2 variables here. So now I have to ask myself what I'm doing. I'm taking half of the product of L and W. So that means that I have to multiply L and W together. I could write it as just LW, or I could write that as L times W. It doesn't really matter. And now we get into a little bit of a weird area, but anytime you see 1/2 the product, you could do a lot of different things here. If I'm going to take half of the product, you could think that you're going to multiply everything times 1/2. You could think that, oh, well, taking half of something is the same as dividing it by 2, right? It doesn't really matter what you choose to do. You could even write it this way, 1/2 LW. All three of these answers here, 1/2 with parentheses LW, 1/2 LW, LW divided by 2 is all three different ways of saying the same thing. Half the product of L and W. And we have shown that. Okay, so now we get on to problems like 5 and 6. 5 and 6 are going to give you the math expression, and you have to go back and explain it in English, in like an English sentence. So the first one, I think these are actually a little more straightforward because you can write them how you would read them. So if I look at this and I see x divided by 3 minus 12, you could easily say x divided by 3, right, minus 12, right? You could easily write it that way, right? So that's fine, but when I go back to reread that, and I say x divided by 3 minus 12, that doesn't really fit how we've done things above, right? We have to do a little bit of editing, right? We know that this 12 is being taken away from x divided by 3. So if we wanted to, we could write it the way that we've been seeing it, right? We could say, hey, we're taking like 12 taken away from, right? Because now we know we're doing minus 12. And then now we look at that, what is it being taken away from? It's been taken away from x divided by 3, right? And as we've seen before, we could say the quotient of a number in 3. 12 taken away from the quotient of a number in 3. Now it's in the format how we've had it before and how we've seen it before. All right, the same thing. Over here we have 5x plus 6. You know, at first glance, we could put this together as we read it and just say 5 times a number plus 6. Or we could say something like this. The sum, let me spell that right. The sum of 6 and 5 times a number. Right? Now, I will say that these are straightforward without being straightforward, right? Once you get the hang of the phrasing and the wording of the English to the math, like you'll get with how you should write it. Also, you will find your favorite ways to do things, the specific way to word something so it makes sense, and that's great. But what I would say is just watch out for things. Watch how things were worded in these examples, how things are worded in your problems. Write those down. And then when it comes down to writing the math expression from the English sentence, watch what you're doing, read, reread, see what you're being asked to do, and at the end of the day, with a little practice, everything's going to be fine. Hope you found this helpful. And as always, if you have any questions, please let me know.